At the White Sands Missile Range in Las Cruces, New Mexico, engineers and technicians are preparing for a very special test. The Launch Abort System is a sophisticated new rocket tower designed to pull a spacecraft away from danger on the pad and during initial ascent. For the first time, all the components of the system will work together. The test not only develops core technology needed for future spacecraft, but also directly improves the chances of crew survival in an emergency. The name of the test is Pad Abort 1. It's the mid-1960s, and the Apollo program is testing its launch escape system. At the White Sands Missile Range, a squatty rocket nicknamed Little Joe 2 launches an Apollo capsule for a high-altitude test. Engineers want to see if the escape system can pull the capsule away from danger in the event of an emergency. The unmanned test shows the escape system works. Years later, an escape system was used for real on a Russian Soyuz rocket. When spilt fuel caught fire on the launch pad, an escape rocket pulled the capsule away from the hazard, saving the crew members' lives. For the Pad Abort 1 test, engineers will utilize the Launch Abort System to lift a mock Orion crew module. The test simulates an emergency situation not unlike the Soyuz incident, where the spacecraft is still sitting on the launch pad. The Launch Abort System builds upon knowledge of the past and applies modern technology and new innovations to make a more capable means of escape for the crew. This technology can be utilized to make any spacecraft safer for human space exploration.
Actually, if you look at Mercury, Gemini, and Apollo, they all had a launch abort capability, different ways. For these capsule-like designs, there's a way to pull it away from the booster and save the crew. So it takes that fundamental idea, but our current launch abort system is actually much better than those systems. With the thrust, with the attitude control system that we have on it, we can actually get the crew away from the vast majority of even very unlikely contingencies we can imagine.
3 newly developed motors will work together on the Launch Abort System to create a new level of control and stability during flight. The abort motor is the most powerful and begins the escape process.
Well, it's pretty amazing. The abort motor is the biggest motor that lifts everything up. It's got about 500,000 pounds of thrust, and it's going to get the whole vehicle up off the ground to achieving about a Mach 0.6 in about 3 seconds.
Tested in Utah, the abort motor utilizes a new style of propulsion that saves space and weight while still achieving remarkable power.
Well, our booster is bigger, so what we decided to do rather than sit it on top of a lattice structure was actually turn it upside down so that the thrust goes up and then turns out on the nozzle, so we have a reverse thrust nozzle. So that's a new technology that we've developed for this. It makes it shorter than we might otherwise need it to be, which is good for mass and other things.
While the abort motor initially pulls the spacecraft from danger, an attitude control motor provides a new level of steering capability to orient the spacecraft.
We have an attitude control motor which has 8 thrusters or pintle valves. So it's a solid rocket motor, single solid rocket motor with 8 valves. These valves can individually be varied to vary the thrust at the 8 different locations around the circumference of the top of the abort motor. It's more stable. It gets you in a better attitude when it's time to deploy the parachute, so it can get the crew module into a much better and more stable position. It also allows us to reduce the weight, overall weight of the Launch Abort System.
With the spacecraft safely away from the danger and properly positioned to deploy parachutes, a third motor, the jettison motor, ejects the entire Launch Abort System tower, leaving the crew module to fly by itself. A forward bay cover is ejected and parachutes deploy for a touchdown. Pad Abort 1 gives engineers a chance to see how the fully integrated Launch Abort System works under flight conditions. The build-up to this test has utilized the diverse talents of NASA centers, commercial industry, and even the military.
We have a lot of different things to integrate. So what we did on the NASA side is we went to several different centers that had expertise in those areas. So Langley has great expertise with structures, so they actually built the crew module for this test. They also have great expertise in loads analysis, so they're actually doing the loads analysis for us on those tests. Dryden, of course, has huge experience in flight tests, mostly aircraft, and so we've been using them to help us with the overall integration as well as actually putting the vehicle together. We shipped the capsule from Langley, and then the avionics came from Lockheed, and it's been the Dryden guys who've been integrating that and putting the capsule together there at Dryden.
The crew module was then shipped to the White Sands Missile Range, where a new 92-acre launch complex was built for both the Pad Abort 1 and other flight tests. Here, all the pieces came together for the first time.
And so out here, we're cooperating with, of course, the Army here at White Sands Missile Range, and there's a NASA center here, the White Sands Test Facility.
The Orion Project Office at the NASA Johnson Space Center is leading the team to test the Launch Abort System, while the expertise of the NASA Marshall Space Flight Center has been called upon for propulsion, assembly integration, and production. The Pad Abort 1 test not only demonstrates new technologies and methods of the Launch Abort System, but also paves the way for better and safer spacecraft design.